Welcome to Studylytics Labs. Myself, Dr. Pulla Sammaya, Professor and Director, Center for Metals and Manufacturing, Department of Mechanical Engineering, SR University, Warangal, and also founder for Studylytics Labs. My experience is 25 years plus. Like, share, and subscribe my channel. Welcome to Studylytics Labs Private Limited. My topic is Technology Readiness Level. We call it TRL. That's a very famous word. Today, every funding agency or DRDO or DST or say by any funding agency, they're asking the product oriented research, the product which we can develop at what stage. So most of the funding agents they are given funding for only products. The product is maybe TRL 3, TRL 4, and finally TRL 9. So TRL 1 to TRL 9. So that we discussed today in my presentation today. So myself, Dr. Pulasamaya, Professor, Center for Metals and Manufacturing, Department of Mechanical Engineering, SR University, Warangal, and also founder for Studylytics Labs. So here is the great sentence is given by one of the eminent professor, uh, Dr. Madhusudan Reddy. He is my guru. And the Technology Readiness Level (TRL), a structured pathway that transforms an idea into a validated, qualified, and deployable technology for real world impact. Right? So this is the importance of the research. Basically, in India, the research interests are systematic approach, objective and unbiased research, and empirical evidence research, replicability and transparency, logical and critical thinking, peer review, and iterative process. What do you mean by research? Research is a systematic and methodological process for inquiry aimed at exploring, analyzing, and interpreting information to answer specific questions or solve problems. So, by following established research methodologies, our investigators collect reliable data, draw meaningful conclusions, and contribute to the existing body of knowledge. In the essence, research definition emphasizes structured inquiry, objectivity, and evidence-based understanding. This is called research. Basically, today the major challenge in the biomaterials, it's a very terrific area to develop the product in TRL 4, 5. Is a lot of funding is available for these challenges. Biomaterials are polymers, ceramics, metals, and composites. For the funding, basically conventional research is converted into advanced research. Most of the funding we expected from the advanced research area. Whatever you did research in the specialization, so but that should be you evaluate the advanced research. So now you see the diagram here very clear resources and technology readiness level. You see TRL 1, the funding agencies, the yellow color, the portion we can see the government and private sector is given a lot of funding. And the curve shows most of the things is a TRL 6, TRL 7, TRL 8, and TRL 9. We have a huge funding from the government sector as well as the private sector also. So the overcoming challenges, the valley of death is a very famous word. So a major challenge in technology development is navigating the funding gap is known as the valley of death, which occurs between early research and later stage commercialization. Many promising innovations stall at this stage due to insufficient resources for scaling and testing. TRLs help identify and plan for this critical transition, improving the chances of overcoming it. TRL research begins in India approximately around 2015. Earlier, we have only conventional research, basic research, or mathematical research. Concept oriented research is we did as long as before 2015. But after 2015, India is major focused on product oriented research, and many startups are initiated after 2015 in the area of advanced manufacturing technology from laboratory validation, that is a TRL 3 and 4, to functional component. That's we focus today. Functional component demonstration TRL 6 within the project duration. So that's what there is a major scope to get the funding from TRL 3 to TRL 6. The development between TRL 3 to TRL 6. The startup culture is increased after 2015 is in India 2,06,000 startups as far as the 2025 data is concerned. In the world, 150 million startups in 2025, up to 150 million startups as well as the 2,06,000 in India startups. That's the reason TRLs ensured structured, risk mitigated, and deployment focused development of new technologies. Our overview of TRL, the Technology Readiness Level Assessment is a structured framework designed to evaluate the maturity of technologies from the initial concept to market ready innovation. This is the basic criteria or basic definition of the TRL. We implement a standard TRL evaluation process that help innovators, startups, and researchers quantify their technology progress, identify gaps, and accelerate their journey from idea to implementation. So this is a very focused area. TRL is required for all the startups, innovators, and researchers to identify their research gaps and technology prove, and it's a very challenging to quantify that, to qualify the product at a different stage. So TRL framework is aligned with the global best practices while being tailored to India's academic, industrial, and research ecosystem. So TRL technology readiness level, the product majorly TRL 3 to TRL 6. TRL 1, TRL 2 is very basic, and no funding agency is considered to give the funding for TRL 1 to TRL 2 research level. That we can do at your basically you start continuously from the research gap, which we collected from the literature, continuous literature. From the last 10 to 15 years, you follow the literature, then you could identify some research gaps. The TRL assessment. Yes. So we need some assessment is required for the TRL. It is whether it is in TRL 1 or TRL 2 or TRL 3, because everybody today, the government or private sector who won't give the funding, definitely they need some assessment to determine the developmental stage of a technology or product. There may be TRL 1, TRL 2, up to TRL 9. To provide objective, transparent validation for innovation maturity. Yes, how much maturity level of the product is there. So that would be guided assess for the TRL to get the funding. To assist innovators, organizations in strategic decision making and funding readiness, and also to establish a common language between the researchers, industry, and policymakers for technology transfer and commercialization. This is also known as the one of the technocrat language. TRL is nothing but. So it's very important for the assessment to develop the product in Indian scenario. Is the TRL level research? Yes, there are some procedure. First of all, process validation completed, that is optimized CAPIC. This is a CAPIC is I am used. I mostly did my research in CAPIC, 3D CAPIC using 3D printing, or CAPIC is using conventional compression molding process or injection molding process. We developed many products. So optimized CRP 3D printing parameters have been established, enabling repeatable fabrication of defect-controlled components with the consistent mechanical and thermal performance. And the second is the defense-relevant component demonstration, that is functional aerospace of components, example ducts, aerospace duct and aerospace bracket, have been successfully fabricated and validated under defense-relevant mechanical and thermal conditions. Number three is performance benchmarking and readiness evidence. Comprehensive performance data benchmarked against conventional materials confirms structural integrity, manufacturability, and readiness for prototype level deployment. Why TRL based product development? Really, do we require in industry? Yes, it ensures systematic technology maturation, readiness, technical and financial risk, aligns R&D with the funding agency expectations, bridges the gap between lab research and market-ready products. For this, the TRL-based product development is required. Funding agencies often evaluate proposals based on TRL progression. Today, you see every funding agency, including DST, DRDO, and ANRF, ISRO, and foreign countries. That is a mutual call between India and other countries. Now, you see that image, a roadmap is given little bit showing from TRL 1 to TRL 9. That is a graphical showing a product evolving from a light bulb idea into a market ready product with the TRL levels marked as a milestones from TRL 1 to TRL 9. So that the visual elements in the image is that shows very clear light bulb and a lab that gives a prototype, factory, society. This is a timeline of rotamer, road metaphor. So these are the some of the developments are showing the TRL 1 to TRL now. That's what the product is very important to attract the funding from the funding agencies. What are the technology readiness levels? Different types of TRLs. That is a TRL 1 is a basic scientific principles observed and reported. Just only is a written statement. TRL 1 is. TRL 2 is technology concept and application formulated. Exactly that what concept is used in which application that we have to extract it. TRL 3 experimental proof of concept demonstrated. This we have did in the laboratory. So X, Y, and Z parameters you have to take and mix in the laboratory and the outcome we expected. This is a purely laboratory experimentation. And TRL 4 is, and whatever you developed in the laboratory, that should be, the component must be validated in laboratory environment. Yes, with respect to temperature, with respect to pressure, with respect to environment condition, the sustainability of the product may be, we are assessed in the laboratory. That is called TRL 4. TRL 5, component validated in relevant environment. Yes, the defense, if you use that product in defense, yes, defense environment, you test that material. If you use in aerospace, yes, that material you have to, our product you have to test in the environmental condition, aerospace conditions, or Navy. Different environmental conditions you have to test after the TRL 4. Now TRL 6 is system and or subsystem prototype demonstrated in relevant environment, and TRL 7 is prototype demonstrated in operational environment. So whatever you develop the product in a laboratory is different, in operational condition is different, because a lot of unexpected forces are acting on the material or product, whether the product is existing, that conditions are not. And TRL 8 is yes, system completed, qualified, and certified. There are some agencies, certifying agencies in India. The product may be, yes, you have to qualify based on, if your product is qualified under various testing, then you can get the certification. TRL 9 is actual system proven in operational deployment. So you see the image also, TRL 1 to TRL 2 is the basic technology research. TRL 2 to TRL 3 is research to prove feasibility, and TRL 3 to TRL 5, that is the TRL 3, TRL 4, and TRL 5 is technology development, and TRL 5 to TRL 6 is technology demonstration. After development, you have to demonstrate the technology also. TRL 6, TRL 7, and TRL 8, these are the system development. So this is a very critical stage, and a lot of experimental procedures and the support from the laboratory is required. And TRL 8 and TRL 9 is system test, launch, and put in the operation. One story we heard many years back. There is a Malaysian story from problem to product. He discovered a winding machine. I really we almost today is 1,000 crore annually earned company. He is a illiterate with a small education. Is a 10th standard education, but he developed a machine called winding machine. So we are the government is appreciated with a lot of I think Padma Shri or many awards with his innovation, and to reduce the pain from the Indian women who wind that machine, who work under the winding machine, lot of pain is reduced. He is also inspired from his mother pain, hand pain, and he discovered that machine. The contest is traditional Pochampalli sari weaving, and the problem our society need is here women weavers spend 6 to 8 hours per day winding yarn by hand we called ASU. The work caused fatigue, injuries, and lost income. No affordable machine is existing for small looms. Then idea and early trials, there's a TRL 1 and 2 by the G. Mallesham from the winding machine is Mallesham is observed his mother's pain and sketched a simple mechanical yarn winding concept using bicycle parts and scrap. And prototype and lab validation TRL 3 to TRL 4, that is built rough prototypes, tested winding speed and yarn breakage, iterated gears and tension control, and refinement and pilot use, that is a TRL 5 and 6, improved ergonomics, safety guards, reliability, machines used by local viewers in controlled settings. And field demonstration TRL 7 deployed in multiple villages, feedback improved durability and maintenance. Pre-commercial and certification, that is a TRL 8, standardized parts, vendor sourcing, basic QA, and that is a quality assurance, training manuals. He designed a lot of things at a TRL 8 for the benefit of the society people. And the commercial deployment TRL 9, a affordable winding machine sold to cooperatives, NGOs, and that can save the hours, injuries reduced, productivity up, and the livelihoods improved. So now we deep into each and every TRL level, what we considered here is. So TRL 1, that is a basic research. Yes, dear friends, this is a everybody can do, but without much effort. The basic research only by the paper, reading the newspaper or reading the article or reading some scientific review, then you can get the idea about this. Objective is for the TRL 1, it's a purely basic research. Understanding fundamental principles, that is a material chemistry and the sensing mechanism studied, self-healing polymer behavior analyzed, literature survey, and hypothesis formulation. You see that theory, concept, and model. And now see the image that polymer structures are is a continuous chains, and different types of polymers you have to mix together. Do you get some other output? Third, another element you are getting. And visual elements is your polymer chains, molecular structures, scientists with the computer and equations, academic lab environment is required. Output from the basic research is scientific understanding, conceptual feasibility. So then you can refer the journal papers and theory models. TRL2, its concept formulation. This is, you see the diagram I have shown, this is we developed in my laboratory, that's the Center for Metals and Manufacturing, rubber cap and eye cap. That's a very critical structures using the liquid silicon rubber and reinforcement with some ceramic fillers to improve the standard of the product. Yes, the diagram shows very clear rubber cap and eye cap, and the sketching also we did in our laboratory to using AutoCAD or the sketching by manual. That's called, we called engineering sketching or digital CAD concept of the product we did in our laboratory. Now, object of the TRL2 is define product concept, sensor architecture conceptualized, material property function relationship established, preliminary design sketches. Now, the output is from the TRL2 is conceptual design and use case definition. And now, hybrid drawn or digital product blueprint, functional blocks, that is sensor polymer interface, and idea boards and concept diagrams. Here is the evidence is required for the TRL2 is concept notes and the schematics. Proof of concept. Yes, you see, there's a all full is developed in my lab. There's a CFP 150 CA30 and CFP 450 CA30. The sample which we developed by carbon fiber reinforced polyether ether ketone at different grades, and TAB2 reinforcement, that is also ceramic powder, and M4 mechanical fastener developed in the lab. And this is my methodology. That is the CFP granules we collected, and we grind in the cryo mill, and we mix with the ceramic powder, and we have stirred together with high speed for mixing all the particles. Then we have to oven, we have heat to avoid the or remove the moisture from the particles. Then we place that entire metal in the compression molding, and you compress to develop the product, and finally the product is developed. So the objective of the proof of concept is lab scale materials synthesis, bench level sensing, and healing demonstration, initial performance metrics recorded. So, by this experimentation analysis, so that is the crack healing animation or signal detection, this is a benchtop experiment. Graphics are nearby screen, and evidences are lab results and experimental data which we collected. We have shown these all the laboratory experimental results for the benefit of you. The outcome is a proof of concept, feasibility validation. And in our center, SR University, center is the Center for Metals and Manufacturing. You see that compression molding machine, and we are given a training to outside people also here. And the parameters are infill density, infill shape, layer thickness, and bed temperature. The 3D printer which were used to develop the products here, and trinocular microscope also are there, vernier digital vernier calipers to measure the dimensions of the product after 3D printing. And acetone also we applied chemical treatment of the 3D printed products to improve the surface properties of the printed product of TLA we did in the lab. And we see the microstructure without acetone and with acetone, there's a lot of difference on the surface of the 3D printed product. Polymer composite, that is a tie bolt peak, which we registered that material in the government bodies called patent office. So this is the one of the project I did from the DRDO. My project title in DRDO is I'm a principal investigator, and the title of the project is an explanatory investigation of Geneva with injection molding, employing a progressive material for fastening applications. As a TGA, and this tie bolt is we are copyright in India because this is our own innovation, and the TIB2 reinforced CFP, and the outcome is TIB2 and carbon fiber and PEEK. We combine together to develop the polymer composite. The strength is we achieved 350 megapascal. TRL4 is a lab scale prototype. The objective is develop working prototype. Product fabricate in controlled lab conditions. Yes, whatever the parameters you have to use to finally with defect free product once you develop after many iterations of your parameters, that parameters you have to finalize. So you have to develop the product or fabricate the product with the parameters. Then the second objective is in a TRL4 is calibration and repeatability testing. So after testing, you have to calibrate that entire product at a different loading conditions. Then third one is the performance benchmarking. You see the image that is on-comb structure and orthopedic artificial leg is designed to support the patient's uh, in a biomedical applications. So that's the reason you can see a small device connected to instruments, oscilloscope and DAQ system, control lab environment. And you see the machine is which we developed in our laboratory. That is a compression molding machine to first physical prototype tested in a laboratory. So under different condition, we test the prototype. The outcome of the TRL4 is functional prototype. Yes, that material is or that product is or that prototype is existing at a different conditions. Yes, that's how the functional prototype. And performance validation. How much efficiency is there after performing that product or prototype in the laboratory. That's called the TRL4. TRL5, relevant environment validation. Here you see that laboratory we tested in NIT Warangal of a shaker test for my own material. It shows excellent performance, resistance to vibrations. So that's what in the laboratory also liquid silicon rubber you can see here. So these are all the test reports. TRL5 is nothing but test reports. TRL4, whatever you tested using various parameters, and TRL5 is completely the reports you have to analyze. So in objective for the TRL5 is test under reality conditions, temperature, load, and fatigue testing, integration with the data acquisition system, reliability assessment. So here is the visual elements are thermal chamber, the vibration table, mechanical loading setup, data acquisition in progress. The outcome of the TRL5 is environment tested prototype and risk identification. Is there any risk? Is there during your testing of that product, then that also you can identify. TRL 6, engineering prototype. So the objectives of the TRL 6 is to develop a fully functional engineering prototype with finalized design, materials, and packaging. Demonstrate reliable performance in a relevant environment, that is the real situations. And the third objective is validate integration of subsystems, mechanical, electrical, and software, and ensure ruggedness, safety, and repeatability suitable for field trials. So this is a completely engineering prototype. Now you see the diagram. There, the people are observed the functioning of the prototype in a realistic situations. Now, this is the published a very good article from April 2nd, 2024. Peter Jelinski is editor-in-chief, additive manufacturing. I much so impressed by reading this article. Now, the outcome is from the TRL 6 is engineered grade functional prototype with the finalized design and packaging. Validated performance data in a relevant environmental condition, because every customer, every industry, they're expected validated data from each and every prototype. An integrated system demonstration, that is a hardware, software, and mechanical, all these three integrated to perform the prototype. So that's what TRL6 is confirms that the technology works an integrated system in conditions close to real world use. An example for the TRL6 here, one project I submitted to CPDCASL DRDO, a novel method for compounding CPTAB to composite metal for the development of high strength composite materials. And you see that aerospace bracket that shows very clear is a very complicated product but a critical design that we can design with the lightweight and low density material, high strength to weight ratio. So it is a carbon fiber reinforced CFR peak made with the 10% choped carbon fibers added in a peak matrix. This CFR carbon fiber reinforced peak have high strength and low modulus of elasticity, and the carbon fiber peak replaces metal in aerospace door fitting, and that is the image for today. I am showing the aerospace bracket for the real engineering prototype for understanding which is required for the aerospace applications. And a TRL7 is a system demonstration, is another example I'm given here. You can see the artificial eye or artificial ear or artificial nose. We can design with the liquid silicon rubber, and fantastically because this is a TRL7 is nothing but a system demonstration. In a medical applications, you see for the purpose of prosthetic rehabilitation, biologically accepted materials such as polymethyl methacrylate, polyvinyl chloride, polyurethane, and silicone are used. Silicones are generally the preferred material by the patient because of its lightweight, flexibility, and lifelike appearance. Now you see the image very clear. She's a lady, is suffered with ear. Ear is not there by born, but another side is their ear. So that the looking appearance is not good. Then what we did is here that ear is replaced with artificial ear. So that could be designed in 3D printing using the liquid silicon rubber. Then the points we consider in the TRL7 is demonstrate the fully integrated system in an actual operational environment, validate real world functionality, reliability, and usability, assess installation operation and maintenance feasibility, collect long duration performance data under real service conditions. So TRL7 is confirms that the complete system performs reliability in real world operational environments, bridging engineering validation and commercialization. Another example is facelift surgery that shows very clear. One old woman, 50 years old woman, the face is one side is a youthful, other one is the aged, but that we can improve. That the skin we have to tighten by replacement of the or inserted with the innovative material called the liquid silicon rubber. That is the biocompatible material that could be replaced with the surgery, face surgery. And other side you can see a lot of differences there in the image. That is the we call the facelift surgery. This is the best example for the TRL7. Pre-commercialization system is called TRL8. So technology readiness level 8 is taking a lot of pain at the level of TRL 8. Now you see that objective is finalize the product design to meet regulatory, safety and quality standards, because the government is needs a lot of approvals. Once you release the product, you should maintain all the regular approve the regulatory board and the safety and quality standards. You meet otherwise the product we cannot release into the market. Demonstrate consistent performance and reliability through extended testing. So rigorously, repeatedly, at different conditions, how to test that product. Complete certification compliance and standardized requirements, and prepare the system for commercial manufacturing and deployment. And you see that the image is very clear. That is a CA peak and bracket, which we could develop. It is a very complicated, but we developed in our laboratory. The outcome of the TRL-8 is market-ready technology with regulatory approval, reduced technical and commercial risk. So TRL-8 is establishes a certified, reliable, and manufacturable system ready for uh, commercial rollout. TRL9, commercial deployment. This is the final stage in the product development. So that is the full scale product production, quality inspection, packaged product, and logistics and distribution, customer deployment, and outcome. You see every image is very very important. You see a smart sensor production line, continuously the product is producing based on the requirement of the customer, and quality after developing the product, immediately that each and every product is individual product is completely inspected in NDT, non-disturbed testing panel, that we discuss or tested each and every product very carefully, then only release into the market. The outcome is here, you see, uh, mm, first of all, applications is in energy, solar systems, solar panels, industrial automation is a huge, confused industrial system that we can simplify with them through our innovations, and smart infrastructure and agriculture. The drone is acting on the spraying the system in the agriculture. That is also latest technology we applied, and the defense and marine structures. The outcome is your TRL9 is a market validated product with proven economic and societal value. Industry, government are continue industry, government of customer adoption achieved, and the revenue generation and long-term business sustainability, and the product life cycle support system implemented, and R&D to market journey successfully completed in a TRL9 stage. That's what TRL9 confirms, that the technology is fully commercialized, widely deployed, and delivering real world value. Thank you for watching my video.